All right, part two. This is part two of function transformations. Wow, I did not realize that that first one was 36 minutes. If you're watching these back to back, I commend you because this one might very well be longer than the first one. I will try to make it not though. So let's just jump right in. So these again are all the transformations, Okay, let's jump right in. So we are going to start off, make sure I do these in the correct order. I forgot to draw a graph over there. But we're going to start off the same, we're going to go the same order we did in part one, except you can notice we are not transforming the parent function this time. So the rules, these rules here, these transformation rules are really actually going to matter this time. Things are going to be a lot different for every single one. None of them are going to come out the same like they did in the first part. Okay, so we're going to have to follow those. Let me draw in a graph here real quick, little grid coordinate. All right, good enough. Okay, so first thing you guys have to look up for is the vertical shift up to. So vertical shift up to, that is going to mean that we're going to take f of x and we're going to add 2 to the entire function. We're going to add 2 to the entire function. But before we do that, let's first find these inputs here. So if I substitute -2 in, 2 times -2 is -4, and then -4 plus 2 is going to also be -2. All right. 1 or -1, 2 times -1 is -2, plus 2 is going to be 0. 2 times 0 is 0, plus 2 is 2. 2 times 1 plus 2 is 4. You guys can see where we're going, plus 2, plus 2, plus 2, plus 2. All right, linear. Linears are easy, all right? Add the same amount, constant rate of change. We need g of x though. We do not know what g of x is. We do know that we're going to transform f of x by adding 2 to the entire thing in order to get g of x though. So let's take f of x down here, and we're going to add 2 to the entire thing. Now, when we add to the entire thing, that means that you need to put parentheses around the entire original function. So 2x plus 2, and then we are going to add 2 to the entire thing. Now, again, this doesn't matter so much when we're talking about linear functions. And if you understand that, you don't have to follow the rule when you're vertical shift up, vertical shift down. But if you don't remember the rule later on when we do absolute values or quadratics or other functions, then things might go haywire. So we're going to add to the entire function. We are now going to have g of x. So when we add to the entire function, is there a purpose to have these absolute values? No, there is not. So there's this middle step where it's just 2x plus 2 plus 2, which becomes 2x plus 4. So in reality, could I just add the 2 to the 2? Yes, yes you can. But the point is you're adding the 2 to the entire function, okay? So we got 2x plus 4. All right, so let's actually plug these in. So 2 times -2 is going to be -4. -4 plus 4 is 0. 2 times -1 is -2. -2 plus 4 is 2. And then, right, plus 2, plus 2, plus 2, plus 2. So we're going to get 4, 6, 8. All right, now we're going to graph both these. So this one has a y-intercept of 2. And then the slope is 2. So up 2, up 2. So that would be f of x. And then g of x, we got -2, 0, -2, 0, and then -1, 2, and then 0, 4, and then right there. Just drawing a couple more to make sure I can draw this perfectly straight for the most part. And that would be g of x. And if you noticed, we did in fact shift it up to. Shifted everything up to. Awesome, perfect. Okay, let's do vertical shift down. So vertical shift down means that we are going to add a value to the entire thing, except we're adding a -2 because we want to go down. So this is a -2, right? If k is less than 0, it's down. So k is less than 0, that means 2 is less than 0, which means it has to be a -2. Okay. So we are going to get f of x minus 2. That would equal the entire function 2x plus 2. And we're going to use the same function. That's going to be the function for every single one that we're going to be transforming. Minus 2. All right, so this is going to change to g of x. All right, there's this middle step, throwing pins. There's this middle step that we don't need the parentheses, so it's just plus 2 minus 2. Oh, okay, well, that is just 2x because those cancel out. So we just have 2x. So g of x equals 2x. Now I'm just going to copy in these values because, like I said, they're going to be the same every time. We're going to get 2, 0, 2, 4, 6. Okay. Now if I plug in -2, 2 times -2 is -4. Why does that not sound correct? That sounds way too low. I subtracted 2. Oh, that's a -2. Whew. All right, yeah, -4. That sounds right. That is supposed to be a -2. Gosh darn, protractor was covering it up. Okay, so yeah, that sounds right. So when I multiply 2 times -1, -2. 0 times anything is 0. 1 times 2 is 2. And then 2 times 2 is 4. So again, right, we moved everything down 2, right? 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is 0. So let's graph these. We got our first one, which is going to be the same as the last one. So we got this point, this point, this point, this point, and this point. Draw our best of our ability, a good solid straight line through the points. F of x. All right, and then g of x. So we got -2, -4, -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. So now we got g of x, and as you notice, the last one was up to, this one was down to. Perfect. Perfect stuff, right? All right, moving a little bit quicker. Maybe I will get this one done quicker than 36 minutes like part 1. We got horizontal shifts. Okay, now this is where things start to really matter, unlike before in part 1. Happening to the variable. So this last one we did, these last 2 we did, it was happening to the entire function. Happening to the entire function. So we circled the entire function, right? It was happening to the entire function, so we circled the entire function. Or not, I shouldn't say circle, why am I saying circle? We put parentheses around the entire function. This case, it is not happening to the entire function, it's happening specifically to the variable. Happening specifically to the variable. So we're subtracting off a value that is either a positive or a negative number, but no matter what, we're going to subtract. It is always subtraction, always subtraction. Might subtract the positive, might subtract the negative. but it's to the variable. So what matters here is if we're going to do a horizontal shift to the right 2, so the first thing we have to look at, if we're going to the right, is that a positive or a negative number? If we're going to the right, h is greater than 0. So that's a positive 2. So this is going to be a positive 2 because we are going to the right. Okay, so we know that. We know we're going to be subtracting off a positive 2. Still subtracting, but we're subtracting a positive 2. Okay, so we got f of x. But in this case, we are subtracting a positive 2. Right? Now, this is where it becomes really tricky. This is happening specifically to the variable. So the only thing I want to put parentheses around is the variable. There's other things in the variable now. Unlike in part 1, there's other stuff than the variable. So where I put the parentheses is only around the variable. So I put parentheses around the variable. Nothing else is inside the parentheses. So this x minus 2 is happening only to the x. I am only subtracting to the x. I am not subtracting the entire function. I'm subtracting only to the variable, the input. Okay? Now for my students, I have this as an example right here. So if the transformation is happening in the inside, so if it's pink, if it's happening in the inside, then you need to put parentheses around, and this is actually to the right too, like the one we're just doing, then you put parentheses around just the x, and you do it to the variable only, okay? Very important. So this is going to change the g of x, but there are a few steps in between, right? So we have a distribution here. So 2 times x is 2x. 2 times negative 2 is negative 4, and then we just drop the plus 2. All right, so now we can say 2x, what? Negative 4 plus 2 is negative 2. Okay, so g of x equals 2x minus 2. So important that you're doing it only to the variable, just like it says in the rules, okay? Let's find some stuff. We already know this stuff. This stuff is going to go negative 2, 0, 2, 4, 6. This stuff, let's find out. So if I plug in a negative 2 times 2 is negative 4. Negative 4 minus 2 is actually going to be negative 6. 2 times negative 1 is negative 2, and then negative 2 minus 2 is negative 4, and you see where we're going, negative 2, 0, 2. All right, you just add 2 every time. All right, so let's graph these. We got this one, this one, this one, this one, and this one. Okay, so that's g of x. So important that you're doing it only to the x. Okay, now we plot these ones. Now we got negative 2, negative 6. So negative 2, negative 6 is right here. Negative 1, negative 4, negative 1, negative 4. It's right there. 0, negative 2, 1, 0, and then 2, 2. Okay, get this on the line. Oh, wait, hold the phone. What am I doing? This is f of x. That's f of x. This is g of x. My bad. Now what you notice is this is shifted to the right too. Well, is it graphically? What do you know? It is. It's been shifted to the right 2 units. I know it's look kind of hard for you guys to see. I don't know why my document camera doesn't pick it up, but it is in fact shifted over 2 units. 2 squares, right? Okay, now we're going to go to the left. Now, if you look at this, it's really important to look at the rules. When we're going to the left, that means h is less than 0. That means h is going to be a negative number. So if we're going to the left 2, that means that this is going to be a negative 2 because it's to the left, because h is less than 0 when we go to the left. All right? So we're going to get f of x minus, it's always minus. When you're doing a horizontal shift, it's always minus. It's just in this case, we are subtracting a negative 2. Equals, now again, you're putting parentheses around just the variable because this is happening inside the function. It's happening directly to the variable, to the input. And we would do minus, the same thing that's on the inside there, we put here. Okay. Now again, this is going to change to be g of x. Some stuff happens on the inside. There's actually going to be 2 steps here because this is a double negative. So this will change to 2x plus 2 plus 2. Then you distribute, and then you get 2x plus 4 plus 2. And that will simplify to be 2x plus 6. So g of x equals 2x plus 6. Okay. We know what all these ones are. Negative 2, 0, 2, 4, 6. Plot that there, there, there. Some tedious work, graphing over and over and over again. That's how you learn. Repetition, repetition, repetition. Okay. So now, hopefully, when I graph this, it will in fact be to the left 2 units. So 2 times negative 2. 2 times negative 2 is negative 4. And negative 4 plus 6 is positive 2. Negative 1 times 2 is negative 2, and negative 2 plus 6 is 4, and then 6, 8, 10. Okay, so let's find out. So negative 2, 2, negative 2, 2, negative 1, 4, and then 0, 6. Ooh, I'm running out of space up there, but I can go backwards. I can go backwards. Right, you guys remember the staircase, hopefully. I always teach my Algebra 1 students by using the staircase method when you're doing linear functions. Okay, so that would be g of x. And is it to the left too? What do you know? It is in fact to the left too. It is in fact to the left too. All right, awesome. Dropping pins over here. That one took a little bit longer. All right, what are we on next? We got reflections. All right, got some fun reflections. So an x-axis reflection, let's look over here. X-axis happens to the whole function. So we need to multiply the entire function by a negative. The entire function. So we're going to have negative f of x equals a negative times the entire function. The entire function. So when you're doing the entire function, you put parentheses around the whole thing because we're multiplying the entire function by a negative. All right, so that's going to change to be g of x. And we're going to distribute the negative. So we get, I don't know why I'm doing that in black, we're going to get negative 2x minus 2. So g of x equals negative 2x minus 2. All right. What do we got? We got negative 2, 0, 2, 4, 6. Point there, point there, point there, there, there. So important that you guys have the rules in front of you, or, I mean, I really doubt you're ever going to memorize them. I mean, unless if you do a whole bunch of problems. So I would just have them out in front of you, written down, or a printout of them. Somehow you can find it. You can Google function transformations, and a ton of images will show up for the rules. Okay, now we need to plug it in. So what is negative 2 times negative 2? Negative times negative is positive. So 4, and then 4 minus 2 is 2. And then we just add 2 over and over again. So 4, 6, 8, 10. Okay. So let's plot these. We got -2, 2, and then -1. I don't like that. I don't like that. I messed up. I messed up. I messed up, guys. Okay. Let's actually do the math instead of skipping around. -2 times -1 is +2, and +2 minus 2 is going to be 0. Plug in a 0, what's -2 times 0? 0. What's 0 minus 2? -2. And then -4. And then -6. We reflected it, so it should make sense that instead of adding, we are now subtracting because we're going backwards because we reflected it. I don't know what I was thinking. So it should be here, and then 0, -2, and then 1, 4, and then 2, 6. That's not 2, 6. That's 2, 6. Oh my gosh, I'm starting to mess up. This is not good. I promise I won't mess up on the next one. I won't do it. What you see here is, right, this is a reflection over the x-axis. So reflected perfectly, that's 4 units, that's 4 units. So bounce, bounce. Reflected over the x-axis. Perfect, just like this one. Reflected over the x-axis. Perfect. Perfecto. All right, let's do the y-axis now. So the y-axis, what do you know? It's happening inside, specifically to the variable. Now, the issue, and you only have this issue for linear functions. I shouldn't say that actually, quadratics do. The point is when you don't have an inside, when you don't have parentheses, when you don't have a radical sign, when you don't have absolute values, when you don't have an inside, you create it. And that's what I've been doing. So let's do this to the inside. So we have f. And we are going to multiply the variable by a negative. We're going to multiply the inside by a negative, so equals. Inside, so 2. And we're multiplying it by a negative. Okay? So if we're doing it on the inside over here, we need to do it on the inside over here. It's just there wasn't parentheses around the variable, so I made parentheses around the variable, and then I did it inside of them. Okay. So this changes to be g of x equals, well, what's 2 times -x? -2x plus 2. Because that didn't change, just drop it down. So we got -2x plus 2. All right. -2, 0, 2, 4, 6. Almost done. It's a long, long 2-part series. Okay. Now, I'm not going to mess up again. I promised I won't. So let's plug in -2. -2 times -2 is +4. And +4 plus 2, 6. -2 times -1 is +2, and +2 plus 2 is 4. Okay, so I see we've done a reflection. Instead of adding, we're going to subtract. So 2, 0, -2. Okay, once you do it at least twice, you see the pattern for linear functions, that is. Okay, so -2, 6, -2, and then 6, -1, 4, and then right there, and then right there, and then right there. So we got g of x, we got f of x. Perfect, and this is a y-axis. So as you can see, reflected over the y-axis. Reflected over the y-axis. Perfect. Love it. All right. We got, please don't say 2 more. Do I seriously have 2 more? I got 2 more of these. So we got 4 more problems. Lordy Lord. All right. I'm just as tired as you guys are just watching. This is, crank this out. Crank this out. Okay. -2, 0, 2, 4, 6. Let's find g of x. We need to find g of x. We are doing a vertical stretch. So vertical stretch, you multiply the entire function by the value a. All right. So vertical stretch is multiplying by a number greater than 1. What do you know? We're multiplying by 2 that's greater than 1. So we are going to multiply the entire function by 2. So 2 times f of x equals 2 times the entire function, 2x plus 2. Change this to be g of x. 2 times 2x is 4x. 2 times 2 is 4. All right, so g of x equals 2x plus 2. Now, why did I do that? I copied it down. 4x plus 4. Son of a gun. Let's just, I'm scribbling this out. G of x equals 4x plus 4. Well, at least I didn't mess up for the last problem. Okay. So if we plug in -2, 4 times -2 is -8. And -8 plus 4 is going to be -4. -1 times 4 is -4. -4 plus 4 is 0. 4 times 0 is 0, plus 4 is 4. Ooh, we're adding by 4, so plus 4, plus 4, plus 4, plus 4. Okay. I'm not going to be able to fit all those on my graph, but I can fit enough of them. So let's do the first function, 0, 2. So this is f of x. All right, so let's plot what we can. I can plot -2, -4 is here. -1, 0. 0, 4. 0, 4. 1, 8. 1, 8. Can I plot that? That's going to be right there. That's all the points I'm going to be able to get on here. So that is g of x. Now remember, a vertical stretch means pulling away from the x-axis. So if this is the x-axis, then we want to be pulling away from, there's actually a point right here, and I'm pulling away from the x-axis. Now what you notice is I multiplied by 2, so this distance was 4, but now it got multiplied to be a total distance of 8. So 4 times 2 is 8. What do you know? I stretched it by a factor of 2 because I multiplied. Factor, multiplied it. I doubled it. I doubled it in the distance it was from x. I vertically stretched it twice the distance. All right. Now I'm going to vertically shrink it to be half the distance it was away from it. So now, and it's still vertical though, still vertical. Vertical is still going to happen to the outside, to the entire function. It just means that it's between 0 and 1, means it's going to shrink. So this is still -2, 0, 2, 4, 6. We are going to get 1/2 times f of x, because that's what we're multiplying by, equals 1/2 times the entire function, 2x plus 2. We transformed it to be g of x, equals 1/2 times 2x is x, 1/2 times 2 is 1. So we get g of x equals x plus 1. All right, so what is -2 plus 1? -1. What is -1 plus 1? 0. What is 0 plus 1? 1. What is 1 plus 1? 2. 2 plus 1? 3. All right. So negative 2. I'm getting tired myself. All right, f of x. Okay, so we plot these points. We got negative 2, negative 1, negative 2, negative 1, negative 1, 0, 0, 1, 1, 2, 2, 3. And that is now g of x. And as you can see, a vertical shrink is the same as compressing it. We have smashed it in to be half the distance. It was 6. Now it's only 3. It was a total of 6 units away. This point was, but now it's only 3 units away. So we cut it in half. All right, it's the same here. It was 4 units away from the x-axis, but now it's only 2 units. So we cut it in half. All right, so we smashed it in. We compressed everything. Last one now. We have 2 more problems and we are done. All right. Horizontal. Right at the bottom of the list. Horizontal. Horizontal happens specifically to the variable, so it's going to happen to the inside. All right. So we're going to multiply just to the variable. So we got negative 2, 0, 2, 4, 6. This stuff is going to happen to the inside. We're multiplying by 2. So we got f of 2 times x equals 2 parenthesis plus 2, and we are multiplying that x by a 2, right? Multiplying just the variable by 2. It's going to change to be g of x. 2 times 2x, 4x. Still plus 2 though. All right, so we got g of x equals 4x plus 2. Plug it in. What is negative 2 times 4? That's negative 8. Negative 8 plus 2 is negative 6. What is 4 times negative 1? That is negative 4. Negative 4 plus 2 is negative 2. Oh, we added 4. Add 4. Add 4. Add 4. Add 4, add 4, add 4, right? Constant rate of change. So let's plot f of x first. So there, there, there. X, I'm not going to be able to get that point on there, but negative 2, negative 6, negative 2, negative 6, negative 1, negative 2, negative 1, negative 2, 0, 2 still, 1, 6, 1, 6, and then 210 would be way, can I fit it? It's kind of way up there. Is that 10? That should be 10. If it's on the line, it's going to work out. So this is a horizontal shrink. So this is actually, and if you notice, it does work because what it's done is it's actually cut the distance in half. It's compressed it. So it was a total distance of 2 units, but now it's just 1 unit away. It was 2 units, now it's 1 unit away. So it did, in fact, horizontally compress it, smashed it in towards the y-axis. So when you're doing horizontal, you're smashing in towards the y, or you're pulling away from the y, or stretching away from the y. Okay, so let's do horizontal stretch now. So again, it's going to happen because it's still horizontal, So all horizontal things happen to the inside. All horizontal things happen to the inside. All vertical things happen to the outside. So we still have, oh, I didn't write g of x up here. This would be g of x. Okay. Still got -2, 0, 2. This is the last one. I'm so happy to be done. I am proud of any of you who have made it through part 1 and part 2 of this video. So what are we doing? We are multiplying, instead of by 2, we're going to multiply by 1/2 on the inside. So f times get 1/2 equals 2 times plus 2x 1/2. So we're multiplying the inside because that's the rule. All right. So this is going to change to g of x equals, okay, well, what's 2 times half x? Oh, well, 2 times half of 2 is 1, so we just get x and then plus 2. So g of x equals x plus 2. Okay, awesome stuff. Got this. All right, almost done. I am so happy. Fun stuff. Now we need to plug in these points. So if I plug in -2, -2 plus 2 is 0. -1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Okay, so it's adding 1 every time. All right, so -2, 0, 1, 1, 0, 2, 1, 3, 2, 4. So we got g of x, and we got f of x. So we stretched it, so we pulled it away from the y-axis. And what do you know? We pulled it 1 unit, and it was also, we doubled the distance now. So it was 1 unit away, but we pulled it another unit, so now it's 2 units. So these ones kind of work backwards. If you're multiplying by 2 up here, but you're actually cutting the distance in half, you are away from the y value. And here you're multiplying by half, but you're actually doubling the distance. So if you multiply by 1/3, you triple the distance. So you're stretching it away from the y-axis, and here you are compressing it towards the y-axis. I'll stop talking though, because I want to, because that was a long video. So it was part 1. Thank you for watching though. I do hope this was helpful. This is I feel like that was a pretty good introductory into function transformations using linear functions. You need to get some rules, okay? You guys need rules. If you do not have me, if I'm not your actual teacher, I would suggest maybe writing these down on a piece of paper. Maybe pause the video, write these down, color coordinate them. These ones are yellow because that's outside, outside, outside. These ones are pink, inside, inside, inside. And then here are the examples for what I mean by what do you do when it's inside? What do you do when it's to the whole function? Okay, so thank you for watching. Hope it was helpful. Give it a thumbs up if you found it helpful. Thank you.